want to go through a basic introduction of two of our higher level derivative rules. So far we've learned 5 basic rules. We've talked about constant rule, constant multiple, the trig ones, the power rule, which is the most common. But what we haven't discussed yet is what if we have functions that are being multiplied or divided. So for example, it's always nice to know when this would be used. Let's say our function was something like 2x plus 3 times 5x minus 2. Now you've got a couple options for this. What we could do, because we're strong with algebra, is we could FOIL this out. And if you FOIL this out, you're going to get 10x squared. Your outer would be negative 4x. Your inner would be 15x. So you'd have plus 11x minus 6. And that's a really easy function to take the derivative of. You could take the derivative just term by term with the power rule. You end up power out front, power 1 less. This is just the coefficient, and so your derivative is 20x plus 11. Now you might be looking at this going, well, you said there's a product rule, what can I do? Now the common mistake is for students to look at it and say, well, the derivative of this is 2, the derivative of this is 5, 2 times 5 is 10. And what you'll see very quickly is, obviously, it's not 10, so there has to be another way. If you were working at things that were more complicated, let's say you had very large polynomials, or let's say you had something like 4x squared times the sine of x. There's no algebra that will help me with this. I can't simplify it like I did up here. So we have to have another rule, and that's where the product rule comes in. So here's our product rule. It's going to be kind of lengthy when I write down the symbols, but we're going to talk about the meaning of the symbols so that it doesn't look jumbled to you. If you want to take the derivative of a function times a function, so that's all this notation is saying. The d over dx is saying the derivative of, and we have two functions that are being multiplied. If two functions are being multiplied and you want to derive them, you have to take the first function, which I'm calling f, times the derivative of the second function. So the first function unchanged times the derivative of the second function, plus the second function times the derivative of the first function. Now you'll notice that both of the pieces, you have basically two terms to this derivative rule, both of them involve the derivative of one, the original of the other. This is the derivative of one, the original of the other. Because it's addition, it really doesn't matter the order that you do it in. So as long as you're doing derivative times original plus derivative of the other one times original, you'll get the right answer. So using the example that we did up here, with our f of x being 4x squared times sine of x, following the same rule, you would take the first function, which is the 4x squared, we don't change it, times the derivative of sine. Derivative of sine, we know from earlier this week, is cosine of x. And then plus the second, which is sine of x, times the derivative of the first function. So we go up here, the derivative of the first function. Sometimes it helps to label these. This is function 1, this is function 2. Derivative of 4x squared is 8x. Now, I don't really like to write it like this in my final answer because sometimes that gets confused. What's the angle? What's not the angle? This is the only part of the angle. So I'm going to rewrite it as 4x squared cosine x plus, bring this 8x in front, or sometimes I just leave space to put it in front, times the sine of x. And that is your derivative. This is the only way you could go about doing the derivative of this problem. Whereas the one that we showed up here, you have options. You could do the first times the derivative of the second, plus the second times the derivative of the first, or you could FOIL it out. It's really whatever your comfort level is. But you run into these ones, especially the ones that are kind of like a hybrid of a polynomial and a trig, that you have no choice. Let's do one more example of the product rule, and then I'm going to show you the quotient rule. So this time, let's do something like this. Here's our function. So our function is 2x cosine x plus 4 cosine x. So we have to think about, when do I need to use the product rule? That's such a common question from students. How do I know if I need to use it? Well, you want to look at, are you taking a function of x times a function of x? Which in this case you are. This 2x is a function of x. Cosine of x is a function of x. You have to use a product rule to derive it. You can't just say, this is the derivative, done. If it was that easy, well, it would be great, but it wouldn't work. This one, however, this is a numeric value. This is a coefficient times a function of x. I don't need a product rule here. This is not necessary to do a product rule. So let's go ahead and derive that. Again, it's the first times the derivative of the second. The derivative of cosine is negative sine of x, plus the second times the derivative of the first. The derivative of 2x is 2, and I'm going to leave myself space so I can just plop a 2 in here. That's the product rule. That takes care of the derivative of this entire first term. So this one term turned into two-part derivative because it was a product. Then over here, I can just take the derivative of 4 cosine x. It is just the derivative of cosine x, which is negative sine of x, and the 4 stays in front. So I'll leave myself room to put that there. Now again, I don't like the look of this because this looks a little bit like subtraction. So I'm going to bring that negative in front. So we have negative 2x sine x plus 2 cosine x minus 4 sine x. So that is your product rule. We'll do a lot more examples in class, but I wanted to give you an idea of the general rule. Now going back and looking at your quotient rule. Quotient rule is a little more obvious when you have to use it. Quotient rule is when you have things being divided, which would make sense. It's the idea that you have a quotient. So you are looking at two functions that are being divided. So here would be the notation. This is saying the derivative of a function divided by a function. This one is a much lengthier rule, and a lot of times I'll refer to it as bottom and top, top and bottom, numerator and denominator. So I'm going to take the bottom times the derivative of the top. So the bottom unchanged times the derivative of whatever's in the numerator, minus the top times the derivative of the bottom, all over, really bad line there, the original denominator squared. Now you'll notice there's only two actual derivative pieces here. We have the derivative here, we have the derivative here, but this is over the original one squared. So just do one example of this and then we'll continue with it in class. Let's say our function is 5x minus 2 over x squared plus 1. Again, I can't simplify this. There's nothing I can do to make this simpler, to make it easier. If there was, I would do it because this is a long rule. So I have no choice but to use this quotient rule because I have a function made up of two pieces that are being divided. What I end up with is bottom times the derivative of the top minus the top times the derivative of the bottom, all over the original denominator squared. Not the derivative of the denominator, the original denominator. Now, what I expect from you as far as to get full credit, I expect you to clean up this numerator. You're going to have a lot of pieces that can be distributed, that can be combined. So I'm going to have 5x squared plus 5 when I distribute, and then minus 10x squared, you have a minus and a minus, plus 4x over, I do not expect you to do anything with the bottom. I would prefer that you leave it as x squared plus 1 squared. Combine like terms, your final answer is negative 5x squared plus 4x plus 5 all over x squared plus 1 squared. And that's the basic idea of how the quotient rule works. We'll have to do a lot of examples for it to become second nature, but at least it gives you an idea of the formula so we can work on it in class together.